Let's get started with the dependency container implementation. I have already created a small sample project with two sample views and some dependencies so that we can use it later on to show some use cases when it's time to use our container. I left a link in the description to download the starter project, but you can also just simply create a project and code along as we implement the container if you're not interested with the use cases of the sample project. And I can show you the sample project. It's just a main view and a detail view as we click from the button here. And I'm using MEVMC with Swift UI, but yeah, it's a different discussion that I will not go into details. And the main module view has two dependencies. Actually, both the main module and also the detail module, they both have two dependencies, an analytics tracker and a networking. Um, Networking is here with the protocol with one method, make network request, and then implementation network services here with a single instance as a singleton. With the implementing this method, of course, it's just for demonstration purposes in a real life application, the networking service will be more comprehensive. And another dependency we have here is analytics event tracking to track some user interaction events. And it's a struct, analytics event tracker that conforms to this protocol. So it's not a user singleton and every page can use its own event tracker. So I want to simulate the dependencies where we need to get a fresh one every time we need one, right? I mean, yeah, maybe in your projects for analytics, you need also single instance, but as an example, I chose analytics to be as a non-single instance dependency that we need to get fresh every time we need one. Okay, so yeah, this is the basic sample project with two views and two dependencies. And now we can actually get started with our dependency container. So I'm going to come here and right click, say new file. It's going to be Swift file, dependency container. So with dependency containers, we can get rid of singletons, as we said, but actually the dependency container itself is going to be the only singleton in the project. So we're still going to use this container as a singleton. Okay, so now I'm going to come here and say final class dependency container, and let's provide a singleton of it as a shared dependency container, and let's add a private init so that it cannot be initialized outside. Okay, so if you remember from the previous video, dependency containers are dictionaries that keep our dependencies as the key value pairs. So the key is going to be the protocol that defines the dependency, and the value is going to be the dependency itself. But I want to be able to have two different type of dependencies. So I want to be able to have instances, like single instances, and I also want to have dependencies as closures, like provided from closures, so that every time I need a dependency, I can get a new one, a new instance of it. So I want to be able to support both from my dependency container. So that means we are going to need to have two different dictionaries. So I'm going to come here and create two different dictionaries. First one is going to be private variable closure-based dependencies. It's going to be type of object identifier, the key, and the value is going to be a closure that takes nothing and returns any. It's going to be empty initially. And object identifier, let's talk about it for a moment. And if I click option and click on it, it tells me that's a unique identifier for a class instance or meta type. So it's the identifier for the type that we can use as a unique identifier. So for any given protocol, we are just gonna use the type of that protocol to access to its identifier. So that means if we have two protocols, let's say protocol A and protocol B, and if you register something for protocol A, that like some dependency that conforms to protocol A, there will be only one dependency that will be registered for that protocol, and same as protocol B. So we will be able to differentiate different protocols from each other. Okay, so now we created for closure-based dependencies. Let's also create one for single instances. So I'm going to say private variable single instance dependencies. Type is going to be object identifier for the key, and the value is going to be any object. So since it's going to be single instance, that means we need an object type. So the values must be any object. Okay, so we have dictionaries, and we will maintain our dependencies with these dictionaries. So it's okay maybe to read concurrently from these dictionaries if two threads need to read values from it. But if two threads needs to write values to it, you might have some problems. So that's why let's control this access to these dictionaries with a custom queue. Because if two threads can try to change these dictionaries in the same time, I'm sure you've seen like exe bad access errors like happening because of some dictionary race conditions. So we might experience some crashes in the future. So that's why let's control this. I'm going to create a custom queue, private let dependency access queue. It's going to be equal to dispatch queue. Label is going to be, let's write some unique identifier like com.dependency container example queue. And then we're also going to need to add an attribute here. So inside here, attributes. That's going to be concurrent. So concurrent means this queue can execute concurrently. So two different threads can execute code in it concurrently. This will help us with the being able to read dependencies concurrently, which is something we want. And also, since we will be synchronizing to this queue, we will see later on, this will also help us with this following use case. So imagine we have a closure-based dependency that executes a closure to be able to get the dependency. And in that closure, before we can provide the dependency, we need to interact with the container to get another dependency so that we can use that dependency to construct the dependency that was originally asked. So since we are going to be using synchronize, we would end up with a deadlock, as we will see later on. But when we set it as concurrent while reading values from dictionaries, we will solve this problem. Okay, we will see more on that later. So now we also have our queue. And while we are writing things into the dependencies, we are going to use a custom flag to make sure no two threads can write in the same time. Okay, so now we need two methods, right? Our dictionaries are now empty. We need two methods, one for registration, one for resolving. But before we write those methods, we will first write the register method, by the way. I want to create an enum. So let's come here and say enum dependency registration type. It will have two cases with associated values. The first case is going to be single instance, and the associated value is going to be any object. And then the other case is going to be closure based. The associated value will be a closure that takes nothing and returns in. So we will use this enum to let the container know what kind of dependency we are trying to register. So now if you come here and write the method func register, and let's give the type, it's going to be dependency registration type, and for interface, the interface is going to be any that type. So we can provide our protocols as the interface type here. So now we are here, we will register our dependencies. So that means we are going to be writing values to our dictionaries, and we need to do it with our queue. So now let's say dependency access queue that sync. So we want to synchronize on this queue. So because we want it to happen right in that moment, no matter what the thread is calling, which thread is calling, right? So we're going to say sync, but we're going to provide a flag here, dot barrier. Because this queue is concurrent for reading values, but when we are writing something, we want it to be not concurrent, and we can achieve it with this barrier flag. So when we are registering a dependency and this closure is being executed, that means if in that moment any other thread tries to register or read values, they will have to wait until this closure is finished. So the concurrency will not be happening until this closure is completed, so that we can make sure only one thread can write at the same time. So we don't have the race conditions. Okay, so now we are here inside this closure. We can actually switch on our type, see what kind of dependency we are registering. So if it's a single instance, we get the compiler automatically name this as any object, but let's say let instance. And if it's a closure based, what we're going to get here is going to be a closure. So now if it's a single instance, we need to add it to our single instance dependencies dictionary. So we can come here and say single instance dependencies. The key is going to be object identifier, and we are going to provide the interface here, that any.type is the key. And it's going to be equal to the value, the instance that is provided to us here. And then in the closure based, we're going to access the closure based dependencies. Similarly, provide the object identifier as the interface and set the closure as the value. So now we are adding them to our dictionaries, registering them. Okay, so that's cool for our register method. And now we can implement our resolve method. But again, before we write resolve, let's create another enum for it. Let's call it dependency resolving type. So it's going to be single instance or closure based. What does this mean is whenever a dependency needs to be resolved, that resolving entity, the consumer of the container, needs to know if the dependency they're interested in is a single instance or if it's a closure-based dependency. So you might be wondering, maybe it would be better if the consumers don't need to worry about it and we can internally somehow solve this. But that would make the container itself a bit more complicated. Because let's say we try to resolve a dependency and we don't know if it's a single instance or a closure-based, then we would have to take a look at these dictionaries and see if there's a match. Maybe we would first check if there's a single instance for this given protocol, and then if there is not, then check the closure-based on, or we first check the closure-based as well. And this also eliminates the ability to have a different style of dependencies for a given protocol. So with this approach now, we can, for a given protocol, register one single instance and one closure-based dependency for the same protocol. I don't know if you would have a use case for it though, but now it's possible. But if you would go with another approach that the consumers don't need to worry about what type of dependency they are resolving, then we would lose this ability as well. So yeah, I like to do it this way to be able to keep the container more clean. But yeah, we can also discuss more about this if you have other ideas on this. Okay, so now we created this enum. I'm going to come here and say func resolve, and there's going to be a generic value that we will be returning later on. And again, we're going to have a type that's going to be resolving type, dependency resolving type. For interface, that's going to be value that type, and the return is going to be value. So what we are doing here is we will return value eventually, and that value is going to be something that conforms to that value, the type, that the protocol we are going to be injecting here in this function. Okay, so again, we will be interacting with our queue to control access to our dependencies, but we should not return value from our own queue because we want to keep that queue internal. If you return something from the queue, then the control will be handed over to callers and they will continue in our queue, which is not something we want. So in order to prevent that, we're going to create a value here. It's a force interrupt value. And then we are going to access to dependency access queue and call sync on it. But this time there is no flag because this can execute concurrently. So two different threads can synchronize on this in the same time. There's no problem. So now again, we're going to switch on the type, single instance or closure based. So let's say first for a single instance, if the user is trying to resolve a single instance dependency, we're going to come here and say guard let resolved single instance equal to single instance dependencies dictionary object identifier for this given interface as value. Else, we're going to fatalError. So there is no instance registered for the given interface. So now you might be thinking like, wow, what are you doing, right? It's going to crash the application. Well, yes, it will crash the application. And in my opinion, this is a better approach because making a dependency container work with optionals becomes more complicated. Let's say this will return an optional value, and then in the call side, what would the consumer do? Because maybe they don't even have an idea about the dependency they are working with. And also, if this project is later on modularized, they don't even have access to that dependency, right? So they don't know what to do if there is no entity they can interact with to be able to provide the default implementation. So it makes everything more complicated and it becomes really harder to work with the containers. So that's why we are using fatalError here. So that means you must be sure that you register the dependency before you attempt to resolve it. But in my experience, if there's a problem here, they are really easy to catch during development, or with the proper QA setup in a company, it's also really easy to catch before they can make it to production. There are other approaches, by the way, of dependency containers where you can have some default implementations. But in those approaches, the dependency container needs to be aware of every dependency in the project. So the dependency container needs to be in the main target, and all your dependencies also need to be in the main target. But this does not scale well because, as I said, if you modularize your project, your dependency container is going to be a really lean package. It will not depend on anything, and so it won't have any idea of what are the dependencies out there. So it does not scale well if you try to have this main big dependency container approach that is aware of all the dependencies so that it can provide default values. So that's why I like to use it this way. And although it looks risky with a properly architectured application, these crashes don't happen in the production. So yeah, we need to make sure we are registering our dependencies before we try to resolve them. But let's say we could resolve it here. Then we're going to come here and say value is now equal to resolved single instance. Cool. And now we are here. If it was a closure-based dependency, we will try to resolve that and can say guard let resolved closure dependency is going to be equal to closure-based dependencies key object identifier interface value is going to be the value we get is going to be closure, and then we call that closure to be able to get the actual dependency from the closure as the value that the consumer is interested in. Else, again, you can just copy this fatalError here. Else we're just going to crash the application. But if all works fine, we can set value is equal to resolved closure dependency. And once we switch on the type and set our value, and we are done with our synchronization to this queue, we can return our value from here. Cool. So now the queue is still internal, and the value is returned outside of the queue interaction to the consumer. Great. So now we also implement our resolve method, and we have our container ready for use. So we have the container, we have two different dictionaries for different type of dependencies, closure-based or single instance dependencies. We have our register and resolve methods implemented. And also we are controlling access through our custom concurrent queue. So now we are ready to use this container in our project, and we can see how we can register different type of dependencies and how we can resolve them. But while we are doing that, I also want to discuss about some other interesting topics. So it's better to do it in another video. And also, before we get there, it will be nicer to write the unit test for this dependency container. So in the next video, we will be writing unit tests to our dependency container to make sure our registration and resolving is working as expected. And also while writing unit tests, we will also see how to interact with register and resolve methods as well. So I will see you in the next video.